Oops, I forgot the last example. All right, so we're also going to talk about differentiability with graphs that have a vertical tangent line. So sometimes it's really hard to tell, but right here, I would actually be able to draw one vertical tangent line that would only go through that graph once, okay? And this is zoomed in pretty well. But mathematically, if this is our function, x to the 1/3 power. See, our tangent slopes could kind of be the same. They're both positive if I would draw that tangent line. So our last strategy won't justify this example. But if I take the derivative, and that's what that's telling you, that's why that's a slope and it's a limit. So if we take the derivative of this function, it's a power rule. Subtract 1, negative 2/3. If we rewrite that nicer, and so what happens is, really the idea I like to tell students is continuous means I can plug in all x values on the original function. Differentiable means that I can plug in all x values into the derivative, okay? So here, if I have a denominator and this is my derivative, I know I can't plug in 0. And so that means at 0, my graph is not differentiable. It is continuous because I can take the cubed root of anything, but I'm not able to, when I take the derivative, plug in 0. So that's another way that you can tell mathematically. So it is continuous, but not differentiable at x equals 0. All right? So differentiability implies continuity. So you might see this written in textbook as D implies continuity. And what that means is if you are told that a function is differentiable, and they'll tell you that in directions, then it means that the function automatically has to be continuous, okay? So it means you can plug in all values into the derivative as well as all values into the original. So that meaning is going to be important later on when you get to directions. So this does not mean that if a function is continuous, it is also differentiable. We just found that out. We had a continuous graph, but it was not differentiable. Graphs with either a sharp point or a vertical tangent line are not differentiable. I also like to say where you have a derivative that does not exist. That's the mathematical way, okay? Because you're not always going to have graphs. And that's it. Good luck with your homework.